Good morning. In this lecture series, we see about the Galerkin method of under the topic of weight residual method. This is the another important one topic to use thing to find the weight residual method to calculate the any type of problem. So one of the powerful and numerical techniques we have to apply for the Galerkin method. So the first of all, so what is the Galerkin method? So as we know that is a transformation of the complex differential equation into the elegant and solvable equation through the weighted residual approximation. So this is the main concept of the Galerkin method, how they can be applied. So what is the Galerkin method? So this method is nothing but the extensively employed across the engineering discipline and apply the mathematics providing the approximation solutions where exact analytical answers to prove the impossible or impractical to obtain. So what is the core principle of the Galerkin method? So this is the solution is approximated as the as a weighted combination, so combinations of the careful choose the basic functions which list the n force that the residual error may remain the orthogonal to the approximation space. So the what is the mathematical foundation of the weighted residual and orthogonality? So the first of all, the define the problem. So when they begin the differential equation, that consider d of u is equal to 0, subjected to a boundary of the with respect to u is equal to 0. So the second one is consider the trial function that is apt for your problem, and we have to choosing the basic function of the your trial function. So this is the more concept, more main important equation to solving the find the problem of the solution and calculate the residual. The residual is we have to assume that. So what is the trial function? After that, you can substitute the general equation. That is your residual function. That residual function should be always equal to 0. So how will our approximation satisfy the original equations? And enforcement orthogonality is nothing but the Galerkin key inside choose the weighted and enforcing. So therefore, the choosing the elegant equations of the weight residual to orthogonal to entering the approximation space and yielding the optimal converging properties. So what are the steps we have to carry in the Galerkin procedure? So first of all, we have to choosing the basic function and the formation of the trial function and compute the residual and impose the orthogonal and solve the linear system and then construct the solution. That is, you are building the approximate solutions is nothing but u of n of x is equal to 0. So let's consider the example of the solving the boundary problem value of the given. So the for example, I give a assume as the problem statement is y double dash plus y dash plus 2y is equal to 0. Let us consider the what is subjected I want to using here boundary condition. So that is the y of 0 is equal to 0 and y of 1 is equal to 0. That means when x is equal to 0, then y function also 0. When x is equal to 1, again the y function of the 0. So after that, you have to choose in the basic function of the trial function. That is the each function is satisfying the both boundary and the mathematical. So the solution of the process is nothing but constructive trial solutions and applying the Galerkin orthogonal conditions, generate the system of the three linear equations, solving for the coefficient using linear algebra, and obtain accurate appropriate solutions. So as a result, the approximation solution is demonstrates excellent and arguments with the analytical solutions with the relative error below the 0.5 percentage of the occurs the entire domains. So why is the Galerkin method is matter? The what is the foundation of the FEA? So is the dimensional reductions and the error orthogonally. This serves as the mathematical backbone of the finite method, the enabling the structural analysis and the computational fluid dynamics, heat transfer simulations, and the electromagnetic magnetic field calculation used throughout the modern of the engineering. So the guarantees that approximation error remain the orthogonal to solution space, significantly improving the convergence rate and numerical stability and solution accuracy compared to alternative discretization schemes. So dimensional reductions is a brilliant converts the infinity dimensional continuous problem into the finite dimensional algebraic system problems that computers can solve efficiently make the precisely intractable problem computational feasible. So, and then is a continuous of the remarkable adaptability and the real world impact. So, while the remarkable adaptability is a swamped the powerful variance, including bound Galerkin and the Petro Galerkin, that is the discontinuous of the Galerkin method, the each extensions applicable the specialize the problem domain. So overall, the let's summary of the Galerkin method. So first we understanding the basic definition of the Galerkin, and we understanding the core principle, how is the approximate solution via shaping and the residual error and the average sense domain. And the key characteristics, what is it called as the mathematical consistent and the systematic system equations. Thank you.